A very warm welcome to my class 12 student. Today we are starting the new topic, that is electrostatic. So to understand the electrostatic student, first of all you have to understand what you mean by electric charge. So an instantaneous property of an elementary particle of matter which give rise to electric force between various objects. Now you have to remember the basic property of the charge, that is are three form. One is additivity, second is quantization, and third is conservation. So first of all we will focus what do you mean by additivity. Means what, student? Suppose a object contain many charges, so the total charge of a system is algebraic sum of the charges present in that object. Means it, let us say with the formula, that is Q is equal to Q1 plus Q2 plus dot 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 up to Qn. So this number of charge present in a system. So if you will add the charges, it is give in the form of additivity. Okay. Now we will move to quantization. So to understand the word quantization, first you have to focus on the word quantum. So what do you mean by quantum? The minimum amount by which the physical quantity can be changed. Okay. So it is the smallest form where you can change any physical quantity. Third is the conservation. Conservation, which you have read in every class, is that charge neither be created nor be destroyed. But here you have to remember one thing. What is that? That is the total charge of the isolated system remain constant. Means if you are considering any isolated system, in that system the charge never be destroyed, or you cannot create a more charges. Sum total of charge remain same. Okay. Now one thing you have to remember, that is effect of speed on mass. This is the theory of relativity which is given by Newton, and what do you mean by that? Let us check it out. We have written here mass is equal to m0 by 1 minus v square by c square. You are saying this is also velocity, and student this is also velocity. So both velocity SI unit cancel and you will only get as a mass in the form of m0. So that's why here m0 represent the rest mass of the body, c represents speed of the light, and b represent velocity. So if you will see dimensionally, it does not violate the dimensionally, because this is also velocity, this velocity cancel together. Here is considered for the mass, and this is also considered for the mass. So this principle of relativity is very important to understand the effect of mass. See, if suppose c, that is speed of light, is greater than the velocity when an object is moving. Here m is the mass when you are applying the velocity, this one to an object, and this is the rest mass. Then what happened? The charge of the body remain constant and does not change with the speed of the body. Means the mass remain as it is and it does not fluctuate with the speed. Now we will move to the basic concept, that is Coulombs law of electric force. What do you mean by Coulombs law? This law is based on the charge, student. It states that the force of attraction, or you can say repulsion. Why we have used these two words, attraction or repulsion? Because if charge one is positive, another is negative, or you can say if two charges either positive or negative, it will create repulsion. So whenever the force of attraction or repulsion between two stationary points, the charges is directly proportional, that I have shown you with the formula, student. The product of the mass of the charges, that is Q1 and Q2, and inversely proportional to the square of the distance between them. If you want to understand with the help of diagram, let me focus here. Suppose this one charge Q1, okay, and this is charge Q2. If we are maintaining the distance like this, and this distance I have taken as R. So what is that? The force what is acting in this body and this body is directly proportional to the product of their masses, that is Q1, product of the charges Q1 and Q2, and this is the distance of separation. Understood? So you know when we are removing the proportionality symbol, what comes? A constant K. And this constant is known as electrostatic force constant, and this is represented as 1 by 4 pi epsilon naught. This epsilon naught means, student, we are considering in a vacuum. Now you have to remember the form value of this constant, that is 9 into 10 to power 9 Newton meter square per second. Coulomb minus 2. Okay. Now this is the vector form of Coulombs law, which also you have to remember because normally it's come as a 1 mark questions. So again, students, see, very well mannered I have drawn the diagram for you. This is, I have taken, suppose I have taken two positive charge. This is plus Q1, this is plus Q2. So this charge experiencing the force F12 and this charge experiencing F21. Now first of all, you have to understand what do you mean by F12 and F21. Let me check it out. F12 means the force on 1, the force on 1 due to 2. I will repeat my words. The force on 1 due to 2. And what do you mean by F21? The force on 2 due to 1. Okay. So as both forces are acting each other, so practically you can write F12 means the force experienced by body 1 or charge 1 due to charge 2. So see, 1 by 4 pi epsilon naught Q1 Q2 R square, but this is the vector, this is unit vector what you have written in class, I think so in 11th. Yeah, so this is a unit vector position which represent the position. So this is R21, this is the cap which we are using for that direction. Clear? Now similarly you can write for F21. See what F21? 1 by 4 pi epsilon naught Q1 Q2 R square R12 here. So this is the direction on body 1 by 2, but this is the force, student, on body 2 with respect to 1. Clear? Now suppose if I will change F21 into 12, what happen? It will come as negative sign. Now student, you have to understand what is the conclusion we are coming from the Coulombs law. So what conclusion you are getting from the vector form of Coulombs law? Let us check it out, student. Sometimes we are speaking it is satisfying Newton's third law. Why you know? Suppose the position vector, that is R21, if I will change to R12, what happen? The direction changes. So positive is converted into negative. Again, if you will change the 4 directions, students, suppose this is F21 and if you are applying the force F12, both magnitude is same but the direction is opposite. That's why the negative sign comes, and when you add together the net force is coming as 0. So this is something like Newton's third law of motion. Now Coulomb force is also known as central force. Why you know? Because it always acts from the center of the charges. Suppose I will draw for you. Suppose this is one position of charge Q1. This is a position of charge Q2, and what we are taking from the center of the 2 point. The distance is always considered from the center of 2 point. That's why it is, and it is also dependent on the line of action. Are you seeing this? See, the center of this charge, center of C, they join together with a line, and this is also make is in the form of, it is an central force. Clear? Now there is some limitation of the Coulombs law. What is that? The electric charge must be rest, means you cannot consider Coulombs law based on the dynamic charges, means the charges should not be in motion. The second point you have to consider that the electric charge must be a point charge, means I cannot take a macroscopic charge, means the charge which is bigger. You have to take a charge which is very small, or you can say a point charge. Third is that the separation between charge must be greater than 10 to power minus 15 meter. As you know, this is 10 to power minus 15 meter is the distance of an atom in a nucleus. So you are bound to maintain this distance greater than 10 to power minus 15. If you will not maintaining, it is come in the form of nuclear. So you have to maintain the distance also.